answers you can get. So the product rule and quotient rule, don't get the quotient rule confused with the difference quotient. Okay, the difference quotient was what we do, the limit as x approaches a of f of a plus h minus f of x all over h versus the quotient rule. Okay, so if we're multiplying two functions together and we want to take the derivative, we don't just take the derivative of one times the derivative of the other. Okay, that's not a thing. It is the derivative of the first times the function of the second, just the regular function, plus just the function, the first one, times the derivative of the second. So think of it as first things first. So first things first, we take the derivative of the first. Second thing second. The second one, we take the derivative of the second. So the g and the f are just what is given. That doesn't change. There's going to be some multiplying, dividing, squaring, cleaning up stuff, but the derivative is the calculus part of it. Everything else is a little bit tedious, but you still can do all the simple adding, subtracting, multiplying, dividing. For the quotient rule, the top looks the same except for instead of plus it's minus. So f prime g minus fg prime, all of that over g squared. Whatever the denominator is, we just take that particular thing, whatever it is, and square it. So product and quotient, if we're multiplying two things together or dividing them and we want to take the derivative. So this first one, g of t equals. So we have two things that we're multiplying together here. Think of this as f of x and this of g of x. Two things right there. So if we want to find g prime of t, we're going to take f prime of x, and you don't have to write this. I'm going to write it right now just so that you see it over and over again. We're going to take f prime of x and then g of x plus f of x g prime of x. So we're going to do those things right there. So g prime of t, f prime of x. So right here, t squared. We bring that 2 down, 2t to the 2 minus 1. So that's 2t. G of x is just what it is, e to the t. Plus f of x. F of x is t squared. G prime of x, that's from yesterday. E to the x, e to the t, e to some letter. T happens to be our independent variable in this problem, so the derivative of e to the t is e to the t. So there is your derivative. Are you talking about factoring out? But that's not an exponent. That's the variable. 2 is considered the exponent, but this isn't power rule. T is the variable in the problem. Next one is your quotient rule. So this is your f of x, and this is your g of x. All right, so we want to find the derivative. So h prime of x is f prime. Okay, so we want to find the derivative of 3x minus 1. So that's from yesterday. If we just find the derivative, we can find the derivative of 3x minus the derivative of 1. Put those together. So the derivative of 3x, this exponent is 1. 1 times 3 is 3. X to the 1 minus 1 is 0. So our derivative is just 3. Times g of x, 2x plus 1, minus f of x, 3x minus 1, times the derivative of g of x. The derivative of g of x, again, just yesterday, derivative of 2x plus the derivative of 1. The derivative of 2x, 1 times 2 is 2. X to the 1 minus 1 is 0, so it's just 2. All over g squared. Now, the only thing, we don't ever have to square that denominator. You can if you want. There's nothing wrong with that. But the numerator we do need to clean up a little bit. We need to distribute this. We need to distribute that. That minus goes to everything. So h prime of x, 6x plus 3 minus 6x plus 2 over 2x plus 1 squared. And then just combine your like terms. So h prime of x equals 5 over 2x plus 1 squared. If you want to square out that denominator, you can, but be sure you do it correctly, because if you make a mistake squaring it, now you went from a right answer to a wrong answer. Okay, so the top, once we found the derivative part of it, that's the calculus part. After that, it's just distributing and combining like terms. This minus, very important that we have these parentheses, because that minus goes to all of this right here, not just the 3. And in a few units, maybe next unit, you're going to have big old long problems again, and one little minus sign will throw everything off. So you have to be very careful. Do not rush through these problems. One little wrong sign makes everything not work at all. All right, here we have our f of x. Here is our g of x. So y prime is the derivative of f. So 2x plus 1. 2 times 1, x to the 2 minus 1, 2x. There's a 1 here, a 1 here. 1 times 1 is 1. X to 1 minus 1, 0, so 1. So there's your f prime times g minus f times g prime 3x squared plus derivative of the constant is 0. So just 3x squared all over x to the third plus 6 squared. And that's the calculus part. That's the hard part. Now it's just multiplying these, FOILing them out, distributing, combining like terms. So we have y prime equals 2x to the fourth plus x cubed, 12x plus 6. And this would be minus 3x to the fourth minus 3x cubed plus 6x squared. That 3 gets distributed in, and then the negative, or the negative to one of them. You don't distribute this negative here, 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 and here. These two things are being multiplied, so it's minus all of this. I would think of it multiply first and then distribute the negative, but either way works. And again, you do not have to square out that denominator unless you want to. Only thing left to do now is add and subtract like terms. So y prime equals negative x to the fourth minus 2x to the third plus 6x squared plus 12x plus 6, none of those are like terms, all over x to the third plus 6 squared. And it's also it's actually a better idea to leave your denominator unsimplified, because if that numerator happened to, like, things canceled and you ended up with an x to the third plus 6, then you wouldn't want to, you would want to be able to recognize that. Oh, sorry, I forgot the x. 12x. 12x. Thank you. Okay, so the calculus part's that first step. Everything else is multiply, add, and subtract. Oh, yeah. Well, we wouldn't ever give you. So, that's why those problems we gave you to start with were not crazy. The biggest you had was a squared or square root. We wouldn't ever give you a fourth or something like that. All right, so now we're back to same directions we've had before. Find the equation of the tangent line to the curve at the point 1, comma, e over 2. equation of the tangent line. Y minus e over 2 equals, m's what we're looking for, x minus 1. So we need to find the slope of the tangent line at 1. So y prime. We cannot split this up like we could yesterday. If you can split it up into 2 and use add and subtract, do that, but we can't do that. We can't say e to the x over 1 plus e to the x over x squared. That doesn't work in the denominator. These are flip-flop. E to the x would be your common denominator, but you can't do that here. All right, so this is our f, this is our g. So f prime, the derivative of e to the x, is e to the x times g minus f e to the x times the derivative of g. 0 plus 2 comes down, x to the first. So 2x. All over 1 plus x squared squared. There's your derivative. We want the derivative, we want the slope of the tangent line at 1 e over 2. So e over 2 doesn't matter, that matters for our equation over there. We want to know what is this at 1. So we would need to find y prime at 1. So we just plug in a 1 for all the x's. E to the 1, 1 plus 1 squared, minus e to the 1, 2 times 1, 1 plus 1 squared, squared. So y prime of 1 plus 1 squared, so we have 2e minus 2e over 4, which gives us 0. 0 over 4, which is 0. So our slope is 0. So y minus e over 2 equals 0. Our equation is y equals e over 2. There's your equation of the line. Like an irrational number? Yeah. Like 2 point, I don't know, whatever it is, 2.7 something. Yep. So there is your equation of the tangent line. If it said, find the derivative, here was our derivative. Okay? If it said, what is the slope of the tangent line, here's the slope of the tangent line. Write an equation of the tangent line, we go another step. So be sure you do what it says. Always do what it says. All right, f of x equals root x times g of x. So you don't have to rewrite it. I'm just rewriting it so you can kind of see a little bit better. Times g of x. We don't know what g of x is. Some function. We just know that g of x is some function. It does not tell us what it is. Let's see. We know a point on g of x. We know the slope of the line at a certain point of g of x, of g prime of x, but that's all we know. So this is an f times g problem. Okay? Something times something, we need to find the derivative. Why do we have to find the derivative of that? Because it says find f prime of 4. So in order to find f prime of 4, we have to find f prime from the given f of x. So f prime of x is the derivative of f. Think of that as, remember, x to the 1/2. We need to change that radical to exponent. So 1/2 comes down in front, 1/2 x raised to the 1/2 minus 1, so negative 1/2, times g of x. F prime g plus f square root of x, or x to the 1/2, it doesn't matter because we're just writing it down. We're going to evaluate. So x to the 1/2 right there, or the square root of x. That is what our first term was. G prime of x is just g prime of x. We don't know what g of x is. So g prime x. That's what it is. That's all we got. All right, we want to find f prime of 4. So f prime of 4 means the x's are all 4s. So 1/2, 4 to the negative 1/2, g of 4, square root of 4, g prime of 4. Plug in a 4 wherever there's an x. Now, some of these we can evaluate, some we can substitute. So, f prime of 4 is, we have 1/2, 4 to the negative 1/2 is the same as 1 over 4 to the 1/2, which is the same as 1 over the square root of 4. So times a half. It told us what g of 4 was. It was 2. Square root of 4 is 2. It told us what g prime of 4 was, which was 3. So we end up with 1/2 plus 6. So f prime of 4, 1/2 plus 12/2, 13 over 2. Yep. 1 over 4 to the 1/2. Okay, so sometimes you're given a function, sometimes you're just given some function. You don't know what the function actually is. So if you're taking the derivative of some function that you don't know what it is, it's just g prime or f prime or l prime, whatever the letters they give you. And you're going to have lots of f's and g's together, and you have to always be sure you use the correct letter. That's why in pre-cal we were picky about letters, because now in calculus it's even more picky. If you use the wrong letter, the answer is f of x equals 4, but you put g of x equals 4, that's wrong. Okay, so be sure you use the correct letters. All right, so f and g are functions, so it tells us, let u of x be the product, let v of x be the quotient. All right, so u prime of 1. If we want to find u prime of 1, that means we have to find the derivative of that right there. So that's going to be f prime of 1, g of 1, plus f of 1, g prime of 1. F prime g plus f g prime. And the reason why is because it told us that's what it was in the directions. But now we're getting all of our information off this table, this graph. Okay? F prime of 1. F prime is the derivative. The derivative is the slope of the tangent line. How easy when there are lines to find the slope of the line. If the point you're looking at is a line, you can figure out what the exact slope is. So, f prime of 1. That means we need the slope of the tangent line of the red at 1. So we go to 1. We need the slope of that line right there at 1. Well, here's a point, up 2 over 1. So that answer is 2. The slope of the tangent line at 1 is 2. G of 1, that's just pulling it out, evaluating. We go to the graph, we go to x equals 1. What's g equal to? 1. F of 1, we go to 1. What's f equal to? Good. And g prime of 1, what's the derivative, slope of the tangent line at 1? Negative 1. And now we just multiply and add. 2 minus 2. We get 0. All right, v prime of 5. That's the quotient. F of x divided by g of x. It told us that. So v prime of 5 is going to be f prime of 5, g of 5. minus f of 5, g prime of 5, all over g of 5 squared. So now we're going to go to 5. 1. There's our 5 right there. All right, so f prime of 5, the slope of the tangent line of f at 5. So we go up to the red, rise 1, run 3, so that's negative 1/3. G of 5, the value of g at 5, 2. F of 5, the value of f at 5, 3. G prime of 5, the slope of the tangent line at 5 on the G graph. So down 2, left 3, so positive 2/3. G of 5, we already found to be 2. 2 squared, we get 4. Now, it's a simple multiply, add, and divide problem. So we get negative 2/3 minus 2, so I'm going to make that 6/3 over 4. So we get negative 8/3 times 1/4. Multiply by the reciprocal equals negative 2/3. And this right here, if you can come up with negative 2/3 without writing this step right here, that's fine. You don't have to show me negative 2/3 minus 6/3. If you can come up with that without looking at it, that is completely fine. All right. This one I'm going to wait and do until Monday because it takes a really long time to do this, and instead of starting it and doing like part of it,